Okay, so I'm recording, and this is chapter 5, which is chemistry. So we will be talking about chemistry starting from the smallest units and building up, building up. This was in chapter 2. Remember when we started from atoms and molecules and cells and macromolecules, organelles, cells, tissues, organ system, and so on, all the way until we get to the biosphere. If you remember that slide that I told you guys, you need to know that sequence, very important to know. So we are going to go through that part by part. So we're going to start from the tiny part and go all the way to homeostasis. So here it is again, starting from atom to the molecules, cells, tissues, organ system, organism, population, community, ecosystem, and biosphere. And I told you that you will be asked about this. So we're going to start from here. Atoms, molecules. We did the cells, but we need to do the atoms and molecules, and then moving on. Atoms are the basic units of the matter. Remember, the cells were the basic units of life, but this is the basic unit of matter. Definitions here are important to know. Elements. This is a pure substance that's only one atom. We call it element. And you when get atoms or elements together, what's connecting them together, we call it a bond. And when you put atoms or elements together, making a bond, you're going to make the next level, which is the molecules. And obviously, molecules together will make the cells. We have a lot of these elements, but the main ones that we have to know, oxygen, carbon, hydrogen, and nitrogen. And you will see how we put them together to make different things. We also have other things like, but in smaller amounts. This is the major, the biggest, the main bulk that we need. Otherwise, we need other things in smaller amounts, and some others in extremely small amounts. We call that trace elements, like zinc, like ferrous, and like copper. So we need very, very small amounts of those, something like these here, the zinc, iron, iodine, in extremely small amounts, and that's why we call it trace elements. And if you do not take it in that small amount, it can be toxic actually. So we're not like, if you we know that ferrous, which is iron, is basically needed for red blood cells. So what if I need more amount, like big amount, in order to build my red blood cells? No, it's toxic. It's toxic. I mean, it's toxic. So we need it in very, very small amounts. So atom. The atom composed of, it's composed of the center inside here, which is called the nucleus, and this contains two things: protons and neutrons. Both of them here in the center, in the nucleus. Protons, the purple ones; neutrons is the green ones. And outside of this nucleus, there are these electrons that are circling around, exactly like the sun and the earth is going around it, or the earth and the moon is going around it. So it's the same way. And we call the electrons, where the electrons are located, we call that the shells. Okay, so inside here, nucleus containing protons and neutrons, and outside here, the shells contain electrons. It's extremely important to know the charge. Neutron, the name give it away. It's neutral. Proton, the P should remind you with positive. Positive. So the last one, electron, is negative. If I ask you, how many protons do you have here, in this one here? Protons are purple. You have 2 here. Yes, this is called atomic number. And this is something that you need to know. Atomic number. What's atomic number? Protons only. And if I ask you protons plus neutrons, which is everything in the nucleus, what do you call it? Mass number. So what's the mass number here? It's 4. You need to know that. So why did you call it mass number? Because protons have a mass, like a weight. Neutrons also have a mass, which is a weight. How about the electrons? No, it's too light, and the mass is extremely small that we neglect it. We don't even count it. So we count only if I ask you about the mass, which is the weight, is the 2 components that have weight, protons and neutrons. And here the electrons in the orbit or the shells. So the atoms, we just mentioned it, atoms are the basic unit of life. Elements is the pure substance, which is 1 atom. Atom consists of what moving around the nucleus? Electrons. Nucleus contain what? Protons and neutrons. Which one is negative? What do you guys think? Which one of the 3 is negative?
Electron.
Electrons. And which ones are positive?
Proton.
Protons. And which one is neutral? The name gave it away.
Neutron.
Neutrons. Yes, neutral neutrons. So here it is. Okay, so this is the level of the atoms. What if I get several atoms, I put them together, connect them together? This connection is called the bond. Like this, like the ball and stick model here. You get the ball and you stick it into another one. So the connection between those 2 is called a bond. It is bond, bond, bond between the 2 brown, bond between the brown and the blue, and so on. But in reality, or in biochemistry, it looks like this. Look at the P, look at the O. You see this dash in between? This is the bond. Look at this, at those 2 dashes here, or those 2 links here. We call that double bond. It's a bond. Since you have an atom here, an atom here, what's connecting them? It's always called a bond. Is it 1 or 2 or 3? Single, double, triple bond. But you can do that throughout all of these. You do not need to know any formulas. You just need to know what I'm telling you. Okay, more than that is too much. But this is, again, you don't have to memorize it, just understand. This is how we write the molecular formula versus the structural formula. Okay, we are not going to ask you like, what is this structural formula is? No, you don't have to know. Just understand that this is how we write it. If you count all the carbons in this molecule, it's going to be 10. So we say C10 means 10 atoms of carbon. If you count the hydrogen here, it will be 16. If you count the nitrogen, 5. Oxygen, 13. Phosphate, 3. So you just put the letter referring to one of those: carbon, hydrogen, nitrogen, oxygen, and phosphate. And you put how many beside it, and we call that molecular formula. Or we can spread it over, and you can actually count. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you have 10 oxygen, 10 carbon, I mean. No, I mean the carbon. The hydrogen, for example, or oxygen is 13. This is 10, 11, 12, 13. If you count it all together, that's going to be 13 oxygen, and so on. You're not asked to like know the details, but at least you know this is called the molecular formula, which is the letter referring to each one of these atoms and how many. And on the other hand, you can spread it in the form of structure, and we call that structural formula. Now, the bonds that we are talking about here, it's called the chemical bonds. What are the kinds of bonds that we need to know? We have three types: ionic, covalent, and hydrogen. If you wanted to make a bond between atoms, you have to do one of the following. Like here I have one atom, and I already know that the atom is nucleus and orbit, or the sphere, okay, or the shell, whatever you want to call it. Inside the nucleus, I have neutron, that's neutral, protons, that's positive, and outside I have electrons. Now I'm focusing on the outside. This atom have electrons in the outside, and this atom also have electrons from outside. I want to connect them. I want to make a bond. There are different ways. Either one electron from this go to the other one, electricity will change and they can come together, attract. We call that ionic bond. I will explain it. Or without losing anything, or without donating or receiving, you can share. Like you have one outside, I have one outside. How about this? If you can see in the camera like this. How about this? Now I have two and you have two. We're sharing. Like I have water, you have food. How about we put the water and food together on a table and both of us share? So we're going to stay together. You need my oxygen, my water, I need your food. So we are not going to detach, because if we detached, we are not sharing anymore, and you will be thirsty, I'll be hungry. So how about we share? Same thing here. You share one or two or three or more of your electrons, and I share mine. So now you have enough electrons, I have enough electrons. These are the different types of bonding. So the first one is called covalent bonds. What's the translation of covalent? Covalent, co means sharing. Covalent bond is sharing. Let me explain it in a simple way, and follow with me as we go. Here is how it goes. This atom, let me show you here. This atom here, this is one shell, and this atom is hydrogen, and it has only one electron in the shell, and the first shell should take up to two. If it is not having enough, we call this atom unstable. It needs to react, it needs to connect, it needs to make a bond with something else. What if it has two, like this, like helium? It doesn't need anything. It doesn't need to react, it doesn't need to share, it doesn't need to make a bond. So if it doesn't have enough, it will need to do something to make a bond. It's reactive. Look at this one right here. The total is 6. 6 neutrons, 6 protons. The number of neutrons and protons normally is equal to the number of electrons. So how many electrons do I have? You have 6. Here is the number here, but the number inside here is for the nucleus, for neutrons and protons. I know, but electrons are equal. So how many do I have in the first shell? I have 2. What's the capacity? 2. So is this one fine? Is it full? Yes. Then I have another 4. I put it in the next shell. How many can I put in this shell? I can put up to 8. And how many do you have? 4. Is that enough? No, not enough. It doesn't, it need another 4. And it will get it somehow. It will react with others to get it. Look at the oxygen. It's 8. Look at the center. It's 8. What's this 8 means? It's the nucleus. So what's the 8? Neutrons, same as protons, same number, not the same charge. So how many electrons do you have? Same number. You're supposed to have, if it's 8 protons, it should be 8 neutrons and 8 electrons. It's equal. All right, so let me do this. And just to make it clear and more obvious, let's say you have different shelves in your house and you have a lot of things. Okay, you have sugar, you have tea, you have different types of coffee, and so on. The shell that you can reach first, the first shell, I can put like tea and sugar only. It can take two only. And the first shell is small like this. I put two. So if you have one, like let's say I drink without sugar, I only have tea. I will put it in the first shell. Is the first shell full? No, it can take another one. So about I put sugar. Yes, put it in the same shell. Now the first shell is full. And now I have coffee. I have three different types of coffee. Where should I put it? Put it in the next shell. And if it is full, let's say take up to 8. So I have 8 different types of coffee. If you have more than that, you go to the next shelf, the third one, and so on. So same thing here. The first one can take up to 2. The second one can take up to 8. And the next one can take up to 8 as well. And so on. So if you look at any one of those, if the outer shell is full, I don't care about the first one, unless if there's only one like this. Here is the outer shell is the only shell, which is the first one. Is it full here? No, it is not. So what's going to happen? It needs to react and make a bond with something else. Otherwise, it will be active, reactive, and it's not stable. How about this one? No, it has one shell only, which is the first shell, and the first shell is full. It's not reactive. It's stable. It's okay. How about this one? Well, give me a minute here. I have 8. I'll put 2 in the first one. I still have 6. 1, 2, 3, 4, 5, 6. Is this shell full? No, it can take up to 8. So what oxygen is going to do now? It needs another 2. So it's going to share with something else, like another oxygen, for example. So I'm going to share those 2 with another oxygen. Any other oxygen is going to share 2 with me. So I'm fine and he's fine, but we're staying together. And if that's the case, sharing, we call it covalent bond. Back to this. So what covalent bond is, here is your magic word that you have to remember. Sharing. Co means with or together. Prefix, co. Sharing. Why do you want to share? I need to share only if I don't have enough electrons in my outer shell and I'm not stable because of that. Here is the example, oxygen. So here is oxygen 8. So 2 and 6. Is that stable? No, it is not. I need 2. Can you see my hand here? Can you guys see this? Here is oxygen 2 in the first shell, 6 in the outer shell. Is it enough? No. What do you need? I need something else to react, either sharing or donating or something. I have to do something that I need to be full. Other oxygen, same thing. So they will say to each other, how about we get together and do this? I have 6 and you're sharing 2 with me. Now I have 8. I'm okay. How about this? Same thing. I will share my 2 with you and you will be full. So sharing is covalent bond. The next one is, it's not 1 or 2. It is way more than that. So if that's the case, if we have like 1 in the outer shell and it can take up to 8, who is going to share 7 with me? That's too hard. So I would rather just get rid of that electron on the outside. I will donate it. And another atom that have 7 and need 1, it will take it from me. Now the problem is, if you guys are not following, or if you need something, let me know. The problem is, when I do that, if I am, here it is, look at this. Here is the example to be more obvious. This is 11. First shell, 2. Second shell, 8. This is 10 so far. There is 1 in the outer shell. Can I share? No, you cannot. Because if you wanted to share, you need another 7. Who is going to share 7 with you? Too much. So I found this chlorine, which is 17. 2, first shell. 8, next shell. This is 10. And I have 7. So chlorine in this case it need 1. So instead of sharing, I'm going to lose, sodium is going to lose this electron and give it to the chlorine. Sodium will be okay because the second shell is the outer shell and it's full. Chlorine will be okay because the third shell is also full. But the problem is, understand this, the problem is, you still have in the nucleus, you have 11 protons, which is positive. You used to have 11 electrons also. It should be equal in order to be neutral. But now I lost 1. So it's not the same anymore. I have 11 protons, which is positive, and 10 electrons, which is negative. So now this sodium, after donating, it become positive instead of being neutral, positive. And this one, it's gaining electron. How many protons I have? 17. How many electrons? 18. So now this will be negative, slightly negative. So chlorine is slightly negative, sodium is slightly positive. They will attract to each other. And if you gain or lose, I call you an ion, an ion. So if you become a positive ion and I become a negative ion, we can attract to each other and make the second type of bond, which is called ionic bonds. Because this is an ion, because losing and become positive or slightly positive. This is also an ion because I gained and become slightly negative. Negative was positive, they come together to make ionic bond. And the best example here is table salt. I think we all know table salt is sodium chloride. This is exactly how we make it. So covalent bond, if you're sharing, this is how we put it together. If you're sharing only 1 electron, we call it single bond. If you're sharing 2 electrons, I call it double. If you're sharing 3, I call it triple. This is if the 2 molecules are the same, hydrogen making a bond with hydrogen, oxygen making a bond with oxygen. Both of them will share equal amounts. But if you do an unequal sharing, like oxygen with hydrogen and hydrogen, oxygen is sharing 2, hydrogen is sharing 1, the other hydrogen is sharing 1. If that's the case, it's unequal. Like if I ask you oxygen, how many are you sharing oxygen? 2. How about you, hydrogen? 1. Is it equal sharing? No. We call that the polar covalent bonds. How about hydrogen with hydrogen? Are you sharing the same? Yes, I'm sharing 1, I'm sharing 1. So we're sharing the same thing? Yes. We call that non-polar. Polar means polarity. Polarity means one side is different than the other. One is sharing 2, and the other one is sharing 1. Are we equal? No, we're not. So this will be polar. There is polarity. There is inequality. This is what polarity means. So what does that mean? What will happen because of that? Because if one is sharing more than the other, they found something very weird. They found that the one that is sharing more become slightly negative, and the one that's sharing less, slightly, very slightly positive, something that they noticed. So look at this. This is hydrogen, sharing 1, sharing 1. This one is fine, this one is fine, and it's equal sharing. So what do you call it? Non-polar. Equal sharing. Why it's non-polar? There is no polarity. Where is the polarity here? Polarity is on equality. They are sharing same number. It's equal. Equal sharing. Non-polar. And how many bonds here? You're sharing 1 and this is sharing 1. It's single. sharing one each, single. How about oxygen? This is oxygen, this is oxygen. This is sharing two, this is sharing two. So it's equal. It's non-polar because polar is unequality. So they're sharing the same thing. And how many bonds do we have here? Two, because you're sharing two. Now look at hydrogen. Hydrogen have 6 in the outer shell, so it needs 2. Here, one hydrogen will come. You're sharing 1. Hydrogen is okay because now it has 2, so it's fine. But oxygen is not okay. So another hydrogen will come so that this hydrogen is okay. It's sharing 1 and it needs 1. This hydrogen is okay, sharing 1 and it has 1. And this oxygen now it's okay because it needs 2, 1 from here and 1 from here. But the problem that's created here is that it's inequality. Oxygen as an atom, as an element, it's sharing 2. Hydrogen is sharing 1. Because of that, hydrogen or oxygen, I mean, will become slightly negative, and hydrogen will become slightly negative. What's the problem with that? Or why are you telling us that? Because this is how water exists. Look at this molecule, H, 2 H's and 1 O. So we call it H2O. If you heard this, H2O. H2 means 2 hydrogen. O is oxygen. And assume that you have another molecule here, H2O, and another one here, and another one here. This is water. This hydrogen being slightly positive, it will attract with the hydrogen, the oxygen, I'm sorry, of the other molecule. And this will, and another molecule, another molecule, another molecule. All these molecules will stay together, and this is the water. When I said the ions, positive with negative, they are attracting together. If they are not, if this is negative and negative, like in this example, let me go back to it to show you. In this example right here. If you put chlorine that's slightly negative with another chlorine that's slightly negative, nothing will happen. They will not attract to each other. How about sodium? And I put another sodium beside it. Are these going to make a bond, ionic bond? No. Both of them are slightly positive. Only negative with positive come together, and this is the electrical charge of these atoms. So remember, an atom that have more electrons than protons, we call it negatively charged. What's a normal? No charge. It's not supposed to be charged. Normally, it's not charged. Translation, electrons and protons equal. 2 electrons, 2 protons. 8 electrons, 8 protons. 18 electron, 18, and so on. They should be equal. If for whatever reason you lost or gain electron, you become negative or positive, and they are going to attract to each other, and we call it ionic bonds. So look at this here. This is sodium, and this is chloride. Sodium, you have 1 on your outer shell. Can you donate it? So chlorine, that's missing 1, or it needs 1. It has 7, so it needs 1. Yes, both of us are benefiting. If I lose 2, my outer shell now is stable. If you gain 1, I'm sorry, if you lose 1, the outer shell now is okay. It's full, contain 8. How about you, chlorine? I have 7. If you give me just 1, I will be fine. My outer shell will be full with 8. So yes, okay, let me donate my electron to you. And when you get it, sodium will become okay. Chlorine will become okay. What do you mean by okay? I mean the outer shell will become stable. It's full. But as a result of that, this one, protons are +1. It's positive. And this electron are more than the protons. It's -1. So they attract to each other, making the ionic bonds. Look at this picture right here. This is a table salt. This is how they come together. Electrostatic attraction. They come together negative to positive. They stay with each other, and this is called ionic bond. Why did you call it ionic bond? It's a bond between two ions. What's the ion? Ion is either gained or lost electron or more. Whether you gained or lost, both of the cases, we call it ion. An ion, you have a charge now. It's not equal. Hydrogen bond is the third one. So I talked about covalent. I talked about ionic bond. The third one is hydrogen bond. And I already mentioned it when I talked about water. So hydrogen bond is this bond between hydrogen that becomes slightly positive because it's sharing less than oxygen, and the oxygen of another molecule, because it's sharing more, it becomes slightly negative. Hydrogen slightly positive, oxygen slightly negative. They come together, and if you analyze the water, here is a unit molecule, 2 H's and 1 O, H2O, H2O, H2O. Is every one of those H2O is all by itself? No, it is not. There is slightly positive hydrogen, slightly attracted to the slightly negative oxygen that's sharing more. They stay together like that, and this is water. Which of what we talked about so far is the strongest and which one of the weakest? Hydrogen bond is the weakest of the three. You can make it and break it very easily. Okay. Individually, if you put this individually, they are going to be weak. Like this molecule with this molecule is going to be weak, and it can break down. If I get the whole water together, a lot of these units together, that's going to be a little bit stronger, but a little bit stronger is still weak. Stronger than it was. It's very weak. So what's the weakest of the three? Hydrogen bond. What's the importance of hydrogen bond other than water? Yes, when we talk about the DNA, you will understand that it's a double strand. And the two strands, the bond between the two strands that's holding them together is hydrogen bond. There is hydrogen bond between hydrogen and oxygen in these two strands, and that's how they stay together. The other thing is protein. Protein consists of different polypeptides. These polypeptides come together with what? Hydrogen bond. How about enzyme? When it works on something, the substrate, hydrogen bond. Antibodies bind to the antigen. What is that? The antibodies is released from your white blood cells. The antigen is like something on the microbes. They attract together by hydrogen bond. So there are a lot of hydrogen bonds that exist in different things, including DNA, polypeptides in proteins, enzyme with the substrate, antibodies with the antigen. The three bonds, ionic, covalent, hydrogen. Which one opposing charge? What do you think? Which one is here?
Ionic, I think.
It's ionic, yes, because ions have a charge opposite, so the ions attract each other. And which one here? It share electron, and this is called, which one share?
Covalent.
Covalent, yes. Which is non-polar? If it is, the sharing is equal or unequal?
Equal.
Equal, very good. And if it's polar, if it is?
Unequal.
unequal. Individually, hydrogen bond is weak. Hydrogen bond two only, that's weak. If you put group together, hydrogen bond are kind of strong. All right. I can stop here and give you guys a few minutes, the remaining whatever 15 minutes or something. So let me stop sharing first. Stop